Welcome to the Explainer. So, if you're one of those focused learners who keeps hearing the massive buzzword blockchain thrown around at dinner parties, but you're still sitting there thinking, okay, but what actually is it? Well, you're in the exact right place. Today, we are completely demystifying this technology. We're going to cut right through the confusing jargon and all that complex math to uncover a real paradigm shift, one that is fundamentally reshaping how we, as a society, establish trust.
Here is our roadmap for today. We're going to kick things off with the centralization problem, then uncover the distributed ledger solution, break down how blockchain actually works, explore automating trust with smart contracts, and finally, we'll zoom way out to look at the decentralized Web 3.0.
All right, let's dive into Section 1, the centralization problem and the hidden cost of middlemen.
You know, we rarely realize just how much we depend on centralized authorities until we're literally forced to pay for them. Take a super basic everyday action. You pull out your phone and order a 500 rupee burger on an app like Swiggy. Obviously, you expect Domino's to get that money, right? But because the app's centralized server is acting as the middleman validating that exchange, they take a hefty service fee. Domino's only gets whatever is left over. We are constantly paying these invisible trust taxes simply to connect with each other.
So, the absolutely crucial point here is the stark contrast between these two models. In a centralized network, you've got a single point of failure. If that one server goes down, the whole shebang crashes. You have to rely on a middleman, and yep, you have to pay their service fees. But look over at the decentralized network. It's peer-to-peer. There is no central server just sitting in the middle, which means absolutely no middleman fees. And because the network is distributed out among tons of participants, it's incredibly resilient. If one node fails, no big deal. The rest of the network keeps running perfectly.
Moving right along to Section 2, the distributed ledger solution, reimagining the register.
Okay, so if we just rip out the central server, how on earth do we keep track of who paid whom? Well, the answer is a distributed ledger. Think back to a traditional school admission register. When you get admitted, your name is written down permanently. But normally, only the school principal holds that one single fragile copy of the register. If they lose it, or, heaven forbid, decide to just erase your name, you have a massive problem. A distributed ledger takes that exact same concept of a permanent register, but instead of one person holding the only copy, imagine 10,000 people holding identical copies that literally all update simultaneously across the globe.
And this framework, it completely flips our concept of data security on its head. A distributed ledger has 4 core properties you need to know. First, it is immutable. Once the data goes in, it cannot be altered or deleted. No takebacks. Second, it's transparent, meaning the whole history is visible to the participants. Third, it's distributed. No single corporation or government holds the data. And finally, my favorite, it's trustless. You don't have to trust human beings not to cheat. You're trusting the math and the computer code. You literally cannot cheat the system, because to change a record, you would have to simultaneously hack the register on all 10,000 computers at the exact same time, which is practically impossible.
All right, Section 3, how blockchain actually works. Cryptography and consensus.
So we have this decentralized network and a shared ledger. Let's look at the actual mechanics of how this builds a blockchain using a real-world example. Imagine 4 friends, Jack, Ted, Sam, and Phil, go out and split a dinner bill. The next day, Phil needs to send Jack 2 bitcoins for his share. Phil requests the transaction. These details are then combined with Phil's private digital key, which is kind of like a highly secure password, and Jack's public key. This requested transaction is then broadcast out to the network. The network nodes check their copies of the ledger to validate, hey, does Phil actually have 2 bitcoins to send? Once they validate it, boom, this transaction is permanently inscribed into a new block of data, which is then securely chained to all the previous records.
But wait, how exactly are these blocks chained together so securely? The secret sauce here is something called a hash. A hash is basically a standard mathematical algorithm that takes all the data inside a block and crunches it down into a highly secure, entirely unique 64-character identifier. Bitcoin uses an algorithm called SHA-256, Ethereum uses Ethash. The genius part is that every new block contains the exact hash of the previous block. This creates this unforgeable digital fingerprint that links every single block together in strict chronological order. If a hacker tries to change even one tiny detail in an old block, its hash completely changes. That instantly breaks the link to the next block, immediately alerting the entire network that someone's trying to pull a fast one.
Now, because there's no central boss verifying all of this, the network relies on a consensus mechanism called proof of work.
When a transaction is broadcast, these specialized nodes called miners compete in a literal race to solve an incredibly complex cryptographic puzzle. This requires massive computational effort, which actually acts as a barrier against spam and fraud. The very first miner to solve it earns the right to add the new block to the chain. And as a thank you for expending all that computing power and securing the ledger, that winning miner is rewarded with newly minted Bitcoin. This brilliant incentive structure is exactly what keeps the whole decentralized network running smoothly.
Let's ground this in a non-crypto application for a second. Look at Walmart. They were facing massive problems with bad quality produce and super high refund rates. I mean, they had this huge complex supply chain and literally couldn't figure out where the food was getting damaged. So, what do? They adopted blockchain technology. They started tracking their produce from the farm, to storage, to transportation, right to the customer. At every single step, the quality was permanently inscribed into a block on the ledger. So when a customer flagged damaged goods, Walmart could just look at the blockchain and pinpoint the exact point of failure in their supply chain. This ultimately eliminated their high return rates. Pretty amazing, right?
Which brings us to Section 4, Automating Trust with Smart Contracts. Code as Law.
So we've seen the incredible power of a permanent, unalterable database. But what if we pushed it further? What if we evolved from just recording value to actually programming it? What if we could use this deeply secure ledger to execute actual complex agreements without needing any humans involved at all?
The answer to that what if is the smart contract. Pushed heavily around 2015 by the Ethereum platform, a smart contract is simply self-executing computer code stored directly on the blockchain. It automatically enforces the rules of an agreement without any need for a middleman. This was an absolute game changer. It essentially turned the blockchain from a simple, secure database into a massive, global, distributed virtual computer where, quite literally, code is law.
Honestly, the easiest way to wrap your head around this is to think of a vending machine. A vending machine takes your money as an input, applies a simple algorithm, if $1.50 is inserted and button A1 is pressed, release the snack. And it just automatically happens. There's no human discretion, no middleman sitting in the machine deciding whether or not you really deserve those chips. A smart contract is the exact same thing, but for complex agreements. It takes data inputs, applies the code, and automatically executes a financial or legal outcome flawlessly every single time.
Let's look at a practical example. Say Andrew wants to start a business and needs some funding. Typically, he'd go to a crowdfunding platform. Let's call it the Lakshmi Chit Fund. That platform acts as a middleman, taking a 1 to 5% commission fee right off the top, and the donors just have to cross their fingers and trust the platform won't run away with their money. With a smart contract, the middleman is completely eliminated. The code collects the donor money. The contract is specifically programmed so that as Andrew hits specific, verifiable business milestones, it automatically releases a portion of the funds to him. If he fails to hit the milestones or the business goes under, the contract automatically and instantly returns the remaining funds to the donors. No commission fees, zero risk of fraud. It is literally just automated trust.
Finally, Section 5, the Decentralized Web 3.0, the Internet of Value.
Now that we've covered the ledger and smart contracts, let's zoom out to the big picture. But before we get to the future of the internet, we do have to acknowledge a hurdle, the number 7. That is the maximum number of transactions per second that the original Bitcoin blockchain can process. Just 7. To put that into perspective, a standard credit card network can handle over 20,000 transactions per second. So while first-generation blockchain is incredibly secure, it has a massive scaling problem. It's just too slow and expensive for everyday microtransaction.
But obviously, tech evolves fast. Let's look at the solutions being developed to fix this exact bottleneck. The first generation was Bitcoin, giving us that shared, secure, distributed database. The second generation was Ethereum, introducing smart contracts and basically turning the blockchain into a global computer. And now, we're entering the third generation with projects like IOTA and the Lightning Network. These technologies focus on parallel operations and off-chain transactions. That means they can process thousands of microtransactions instantly without clogging up the main database. They are actively solving the scalability bottleneck right now.
If we chart the history of the internet itself, this whole evolution becomes crystal clear. Think about it. In Web 1.0, the internet was just a place to read static information. Then came Web 2.0, the read and write era. This gave us dynamic social media and the gig economy, but it came at a cost. It centralized all our data and power into massive tech monopolies and giant, vulnerable data centers. Now we are building Web 3.0. This is the read, write, and value era. It relies on decentralized peer-to-peer blockchain networks, completely returning data ownership, privacy, and true economic power directly back to the users.
And guys, this isn't just theoretical sci-fi stuff. It is happening right now through decentralized applications, or DApps. Look at these alternatives being built to challenge the tech giants. You've got Steemit, which is a social network a lot like Reddit, but it automatically rewards its users with cryptocurrency for posting popular content. There's OpenBazaar, an e-commerce marketplace like eBay, but because it's peer-to-peer, zero listing fees. Storage offers cloud storage, just like Dropbox, but your files are encrypted and spread out across user nodes, meaning no central company can ever access your data. And Slock.it literally ties physical property, like a smart lock on an apartment or a rental bike, directly to a blockchain smart contract. The decentralized internet isn't coming, it's already here.
Well, we've covered an incredible amount of ground today, from the painful flaws of centralization all the way to the beauty of the distributed ledger, cryptography, smart contracts, and Web 3.0. I want to leave you with a final thought to really ponder. If the blockchain is truly an institutional technology, meaning it fundamentally changes how human beings organize and trust one another, rather than just being another piece of information technology, how will this decentralized internet of value ultimately reshape our global economy? How will token economies and automated trust disrupt the centralized tech giants that disrupted the world just a decade ago? It is an absolutely fascinating future to consider. Thanks so much for joining me on this explainer, and keep learning.